Hi, I'm Kurt Plattenberger with RF Cafe, and I want to give you a short introduction to my newest product, the Wireless System Designer. It's an Excel spreadsheet. It's pretty sophisticated, but it's easy enough to use if you're familiar at all with how Excel works. I built it in the 2007 version of Excel to make it compatible back to at least that far for people that haven't updated, but it's been checked all the way up through the latest version of Excel, which is the 2016 version. I'm going to just give you a quick run through of the features. This isn't going to be a tutorial on how to use it, but I've built just a sample FM radio receiver just to show you a little bit how it can be used, but it's up to you for however you want to use it. So let's get started. This is just the entry screen. I have a few of the more important features listed here, and there's hyperlinks that go to different locations within the spreadsheet to get right to them. You can also go to the RF Cafe website to see what's going on. Now, I'm not going to bother clicking on any of these now, but real quickly we'll jump over to the system definition screen. This is the main screen that has all the gory computational details on it. It's pretty big. I'll zoom way out here. You can see it's got a lot of cells full of information, but we'll get into that in a few minutes. The next tab over is the help worksheet. This is very extensive. It has a lot of detail in what's going on, including some of the formulas. And a lot of this information is buried in the mouse over hints that are on the system definition page. If you're familiar with Excel, when you see this little red triangle up in the corner of a cell, when you hover your cursor over it, it gives you a pop-up type of a hint. And I've got many of these all throughout the spreadsheet to give you on-demand access to what the functionality is, so you don't have to go look it up. But if you want more detail, just go onto the help screen. You can also go to the RF Cafe website for Wireless System Designer, and there's more information there as well. These icons for building your system block diagram, they don't have any functionality. They're just little graphics, and I've provided a pretty good bunch of them to start out with here on this icons page. You can add your own. I've just arbitrarily set them to 58 pixels wide by 32 pixels tall, just because that's a convenient size. You can see enough detail to make them useful without being too big, but you can create your own. You can make them any size you want and plop them in these cells, and you're good to go. And then finally, I've got a revision history page. When you get the file, the pages that are locked that are not unlockable, that is, I don't provide a password for, is this revision history, the help page, and the start page, and that's just because there's really nothing on there that you need to mess with. The icons page, there's no locking on it at all for the cells. Everything is completely accessible. The systems definition page is locked, or in Excel terms, protected to begin with, because I want to make sure that you don't accidentally overwrite the cells with the formulas and all the formatting and structure on it. For instance, you can go in any of the blue cells, both the light and dark blue background cells are editable. You can go in and change those values at will, and everything responds the way it's supposed to. If you try to edit anything in any other cell, it'll just give you the standard protection error warning that's given by Excel. These brown cells here, these are formula cells as well, so if you try to change anything in them, you're going to get an error. I do give you the password for this sheet in case you want to unlock it for any reason. If you want to add or delete any of the columns for the different stages, you can do that. Just be sure to relock it again when you're finished so that you don't accidentally overwrite any of the formulas that are in the cells. I recommend not unlocking it at all, just to be safe. If you don't want a particular stage for some reason, you can always just go up here, say you don't want, if you look here, there's 25 stages that are shown to begin with. I'm only using 15 of them. So if I don't want all these stages that have no effect in there, it's simple enough just to highlight it and then do the hide cell, and then you don't see them anymore. It makes it more compact. And then if you want to see them again, since they're still there, all you have to do is just go and highlight the cells or the columns on either side of the hidden cells, right click and do unhide, and you get everything back again. So rather than going to the trouble of deleting or inserting columns, I recommend just hiding the ones you don't need. And if they happen to be in the middle of the cascade structure and you just don't want something anymore, say you don't want that filter in there, you can just put no effect or null values in these cells, like make the gain 0, noise figure 0, the intercept points, make them some big number like 200 or 250, something like that, so that it has no effect on the cascade. But then once you hide that column or columns, the numbers that are in the cells are still included in the overall calculation. It's just that you don't see the results on the screen and they don't show up in the chart. So again, you can insert or delete columns if you want to, but it's much easier just to hide the ones you don't need anymore. A couple features of the spreadsheet that I want you to see, and of course it's all completely documented too, is because the spreadsheet is so tall, I have it built vertically for all the computational cells with the cascade going horizontally, because it makes it easier to, if you do need to insert or delete columns for any reason, everything is within that individual column, so you don't have to move to a bunch of different locations within the workbook or on the worksheet itself in order to copy, to make sure that everything gets included for that particular stage. And what I've done is provided these drop-down menus here, so it'll take you to the different areas in the chart, so you don't have to keep scrolling up and down the thing. It can take quite a while it can be annoying to have to keep going back and forth, so I provided these drop-down areas. There's 20 different charts that are predefined for you here. You can make your own. You can change the data sets that are in the Excel charts just like any other Excel function. There's nothing special. You can go in and add different data series to the chart if you want. But I do provide a drop-down menu on the charts too, so that you can go to whichever one you want. They're actually stacked horizontally in the Z-axis on the screen, and I just wrote some VBA code that goes in and pulls whichever one you select to the top of the stack, so that it just makes it a lot easier that way. You don't have to go all over the place trying to find the chart that you want. On the charts, point out a feature here. I've got tolerances that you can add to every component for each of the different parameters: gain, noise figure, intercept points, 1 dB compression point. And the way the charts are set up is the nominal value, which is in the top part of each line here, the light blue, is represented by the columns, the green columns. Again, you can change those colors to anything you want. So that shows the nominal values, and then the minimum and maximum values. The maximum is the red here, the minimum is the blue, so you can track that throughout as well. As with everything else in Excel, you can delete them, you can change their colors, line width, styles, whatever you want. I just found this to be pretty useful. Let's see. I have because of the way the charts are stacked on top of each other, if you do add or delete cells for any reason, you're going to want to resize the charts so that they just cover the number of components that you have and the number of columns. And I like to line it up with the center of each one here, but you might like to line it up with the edge to show that it's at the output of it. However, to make that easier, I provided a place to define the where the left top corner is, and then how wide and how tall the charts are. And if you press this Align Charts button, I'll go ahead and do it, it's not going to change anything. It goes through and it sets all, right now there's 20 of them, it sets all 20 of them to the same settings so that everything's nice and neat. Again, it's just a convenience feature. Coming down here, the input system overall parameters I have, you set your input power down here, what your temperature is, that'll affect the noise calculations. Minimum signal to noise ratio, that'll affect down here later what your some of the other parameters. Let's see. Include VisWar. I have a place to enter the input and output VisWars, and just using the standard VisWar amplitude error formulas, you can either have it included in the gain calculation or not have it included, depending on what you put here. Again, I provide drop-down menus where they're applicable, just so that you don't have to type in yes or no or y or n, something like that. So you really need to use those drop-down menus. The little down arrow shows up automatically in a cell that has one. When you have the VisWar included in the gain, the cascaded gain calculations, it also affects all of the calculations that use gain, which are just about all of them. So keep that in mind. I have over here, because all of these input cells are error checked or error trapped in one way or the other, I put a place here for the minimum and maximum decibel and power numbers that you can put in here. Right now they're set at 250, so if I try to put a value of 300 in here, it just says that it's higher than what I set for the limit. And the reason I do that is because if you look at these charts, gain's not a problem, but something like IP3, you see how at the very beginning, before you have, when you have a bunch of what I'll call a null value, something that doesn't really affect the output, the calculated output number, you start out, you put really big numbers on there, and it has the effect of compressing the area in the chart that is what you really want. So I put a limit on there just as a reminder to yourself, so that you don't, when you use auto scale on the charts, which is the way Wireless System Designer is provided, you don't have really big values here, so that you can't even see what's going on in the part of the system that you're interested in. You always go in, again, like regular with Excel, you just select the vertical chart format axis, and you can put the maximum. In this case, it looks like 50 is where we're really going to be. And then now these are off the scale, but you have more useful data in the area that is providing useful results. There's the noise figure, gain. All right, so continuing down, there's also the ability to specify filters, and you can put filters in every stage if you want. Not everything that has filter specifications has to be a filter. You might have another component, an amplifier or a circulator or something like that, that has a frequency response that's nonlinear that you want to model in the system. So you can pick one of these standard options. I have, again, used the drop-down menus provided: low pass, high pass, band stop. You can use any of them. They use the standard textbook formulas, nothing special in there. And for filter types, you can choose the null, which is the dashes or no filter. You can do a brick wall, which is just a flat response in the pass band and infinite rejection in the stop bands. I put a practical limit of minus 250 dBm is the lowest power, again, just to keep things from getting ridiculous, because if you have a really high order filter and you're way out of band, you could easily end up with a couple thousand dB of gain, and that's not realistic and not useful, so I put a limit on it. And then Butterworth and Chevy-Chev, so again, standard textbook filters. There's some error checking that's built in here too, just to make sure that you're putting all the data that you're supposed to have. Filter order, if you happen to not put a filter order in there, the error comes up down here for N for the N number, the filter order number. You can, even though in real life you're usually limited to integer values for filter order, but since real life filters are never perfect anyway, you can use a non-integer filter order in here and it still calculates just fine. So it might be able to actually make it approximate a measured filter more closely than if you were restricted to just using integer numbers. Since Chevy-Chev filters require a ripple designation, I also check to make sure that you have the ripple number in there. If you don't, the R shows up. And then upper and lower cutoff frequencies, the band pass and band stop need both. The low pass requires a upper cutoff. The band or the high pass needs a lower cutoff. So it'll tell you, it'll warn you if something's missing there. And it calculates based on your inputs what the center frequency and bandwidth is, and it calculates what the Q of the filter is, the Q being the ratio of the bandwidth to the center frequency. Again, all standard type calculations. Going back up top to the cascaded parameters, just gain, noise figure, second order intercept point. You have to define it relative to the output, but I calculate reference to the input just so you can have that information on hand. Third order intercept point, 1 dB compression. I put an output max power cell in there just for you to use as a flag for yourself, so that if at any point along the cascade your gain would cause the power, assuming linear power, to exceed a certain value, and you want to make sure that you're aware of it. If it happens, you put that number here, and if it's exceeded, then I'll throw a flag up down here for you. No big deal. I also provide a couple areas for you to define your own set of parameters, and there's a place for formulas that reference those parameters farther down the spreadsheet. In the mixer and LO specifications, you can put a frequency translation in every stage if you want. Not much chance of doing that, but you can do it if you want. And here, the center frequency of the LO, you can select whether you want the upper or lower sideband. If you have a frequency specified and you don't check a sideband, I give you a sideband flag here just so you remember to actually set one. You can put in a trial frequency just for use within this part of the spreadsheet, and it calculates what the upper and lower sidebands are for you relative to that LO frequency, again, just for your use here, so you can make sure you've got your numbers right. And I check for frequency inversion on each stage to see whether or not it exists. And on top of that, you can see on this stage it doesn't exist, but on these two it does. And on top of that, at the very output of the cascade, I do an overall calculation to see if inversion exists at the output. So if you have an even number of inversions, you end up with no inversion at the output. If you have an odd number, it's inverted at the output. It's that simple, but I just put it in there for you as a reminder, warning, whatever. Power supplies, you can specify up to 4 different power supplies here and put in the current for each component or each stage, and it calculates the total and then gives you an overall total at the output over here in terms of amperage and watts power. There's also a place to enter on the bill of materials all the relevant information, including both the cost and the weight of each one, which is then tallied at the output of the system over here. And you can put in a date, and then this column or this cell right in here will take a look at all the dates and tell you what your latest date is. So that's the long pole, as it's referred to in scheduling, as far as the latest expected component arrival for delivery. All the cascaded values are calculated down here. Notice all the cells are brown, which means you can't monkey with them, and as long as you leave the worksheet locked or protected, you can't accidentally overwrite anything. I report the nominal and then the max and the min for each one of the values. And what I've done over here is, some people, when they're looking at the minimum and maximums of values, the noise figure, intercept points, they might not want the gain variation included in that calculation. So you're looking at just the variation of these parameters with the nominal gain to see how everything changes. So you can either include the gain min-max values in the min-max values of noise figure, IP2, IP3, and or P1dB, or you can not include it in there. So you're looking at, with nominal gain, what is the variation due to just that particular parameter itself. With RF Cascade Workbook, the gain variation was min-max was always included in it. Some people didn't like that and had to go back and change the variation.